Please welcome Shane.
Thank you, and good morning. How's everybody doing? Good, good, all right. So I'm going to be a little bit controversial. Philip just said a lot of the things that I'll reinforce in some ways, but what I want you to get out of this is not necessarily just feel good, this is what we can do or what we're going to do next, but what we're doing wrong and how we can improve. So I want to start with a little background of what is information technology. We kind of forget some of these things. Many of you probably already know them, but a lot of times we think this is information technology, where we put the computers, do things like that. Or we think this guy's information technology. Our classic data scientists trying to keep the dinosaurs from getting out and holding that all in place. That is not really what information technology is. Information technology really started in 3000 BC when we introduced data storage for the first time because we created writing. So now, instead of just talking with each other, we could store information and we could store it over space and time. That was a huge leap in technology for the human race. Then in 1450, we did something that was really important. We decided that information technology could be duplicated fast. So it took a long time to duplicate information technology before this time. Now we can duplicate it quickly and distribute it quickly. Huge jump for us. Then in 1941, we did something that was incredible. We changed how we could use information technology. We could store it faster, we could move it faster, but the most important thing we invented this last century was the ability to process data. We invented the ability for machines to process data. We invented software where we can make machines that look at data and turn them into information in a way that doesn't require a person. Changed the world, and it is now changing the world in much bigger ways. 2007, the iPhone came out. There were ways to distribute data wirelessly before that. The iPhone made it in mass. Everybody now has a smartphone. All of you have a smartphone. All of your grandparents have a smartphone. All of your parents have a smartphone. Your kids probably have a smartphone. We have data with us everywhere and software that can do amazing things. And we have cloud computing that lives out there in the ether and does computing that can't happen on our phones. Incredible information and incredible power. So I want to demystify big data a little bit, and I want to tie it to software because it's changing the world. We're changing, Philip just talked about how it is changing what's possible in industries. We're changing how an industry can think, how people can think. Machines are thinking. It's amazing. Industry disruptions everywhere. We have cars that are driving. We have warehouse disruption where we're shipping things automatically from warehouse to warehouse based on what machines think people are going to buy. And one person can do the work of not 1,000, but tens of thousands. And that's where software changes the world. I want to make sure we're clear. Big data and data is worthless. Data is worthless without the software and the machines and the work that does work on data. So I want to spend just a few minutes talking about why software itself, the nature of software and what it does, is fundamentally different than any other industry because it's software that changes everything. It's not the data, it's the software and what we do with the data. And if we start to think like that, if we think like software engineers, if we think like Google does or Facebook does in this industry, in our industry, then we will disrupt what's going on. So Steve Jobs said something that's kind of neat. He said, and he learned this early on in his career, that software works fundamentally different than any other industry in existence. In most industries, if you get a 2-to-1 difference between somebody that's mediocre and somebody that's amazing, that's incredibly rare. You almost never get double productivity out of any person, any one human being between mediocre and a great person. Even in sports, the last place in any event to first place in an event, even across multiple heats, is usually about 30%. It's never 100% difference. Well, software is different. A mediocre engineer and a great engineer may be 50 to 1, 100 to 1 difference in productivity and what they're capable of. So let me illustrate that a little bit because that's hard to grasp. So we have a mediocre person, and then a great person. A great person might be up to 50% bigger. That's illustrated there in that second one. A person that's just the best in the world may be 100% better than the mediocre person in whatever field we're talking about. Huge difference in productivity or whatever they're trying to accomplish, whether it's a race or drilling a well. If we introduce machines, we can see now we have a machine that's 4 times better than the best person in the world. That's a huge increase in productivity. Well, this is what it looks like if we say an engineer is 50 to 1 difference. If we say they're 5,000% better than the mediocre engineer. This is what Steve Jobs was saying, and he probably underestimated the difference. And I'll talk a little bit about why. And it's because software deals with things that are different, and here's why. Speed, scale, and leverage. I'll get into each one of these and tell you why software is different and why it is the fundamental thing that will change our industry, not just big data. So let's talk about scale. A fast horse in the Mongol Orkut network was able to transfer information around the Mongol Empire at about 40 miles per hour. So they would take a horse to a station to a horse to a station. About 40 miles an hour is as fast as they could go to get a document from one side of the empire to the other. When we introduced technology, we went from 40 miles per hour to 670,000 miles per hour in the way that we can, the speed at which we can transfer information from one part of the world to another part of the world. Huge difference in speed and pace. The speed at which information can be stored changed fundamentally. It took a man about 4 years to transfer, working about 18 hours a day to transfer the Bible and hand write it all out. Well, now we can do that in milliseconds. We can move it in milliseconds. And then speed of information processing. So software can do processing. Software can think faster and look at more information than any of us collectively can. So speed's a huge difference in how it can work and why software engineers are so much different in terms of their productivity. Then software can scale. So it's space dependent versus space agnostic. If I were to have 1 million books in this room, it would take up most of the room. If I were to have those same books, 1 million of them, in digital form, I could keep it on a small part of the hard drive on my iPhone. High cost versus low cost duplication. It costs quite a bit of money to create a good, to create a widget, to create an iPhone. If I want to make an iPhone, it costs a lot of money to do. I have warehouse space, I have manufacturing that I have to do, and I have lithium ion that I have to mine. It costs a lot of money to duplicate things like the chairs you're sitting on. Well, if you have a virtual chair or a virtual thing, it costs almost $0 to duplicate. So I can duplicate it, and I can duplicate a thing to anybody in the whole world, and it's why Facebook, for example, can serve 2 billion users all over the world, and they have no offices, they have no customer-facing offices, and they only have about a few thousand engineers serving billions of people. Nothing else works that way. Nothing else can scale that way. Because we can also, slow versus fast distribution, we can take a thing that we made and we can distribute that thing, if people want it, to everybody in the world. Everybody that has access to a store, an app store, the Google Play Store. Everybody can have it almost instantly. So we can scale like it's never been before. And here's where it all comes together, and it's leverage. So one of the key principles of software engineering is never write the same code twice. You should never do it, because you don't have to. Because I can scale it and copy it for free. I can give it to everybody in the world for free. And everybody can use that same code without ever having to do that one thing ever again. Then I never have to produce the same data twice. If I think about GIS data, if I think about what Google offers me in their APIs, or various other APIs that I can get access to, I don't have to recreate data if the data is collected in a good way to start with. So I can have leverage. I don't have to write anything twice. I don't have to get other data twice. I don't have to remake that data. And then I can engineer and manufacture it once. I don't have to think of an idea. Everything and then get it manufactured. All that is the same process. I can think about an idea, do the engineering, and then I'm done. And then I can distribute it to everybody in the world that wants it, and I can distribute it to them in milliseconds. Huge leverage compared to any other industry that's ever been. And here's where it gets exciting. And here's how engineers today are using all of that leverage. And that's software that tests software. I don't need an army of QA people testing to see if my software is good. I can write software that tests my software. And I can test that software at scale. And I can test it every time. And I can test it with every line of code. Good engineers will do this. And they'll be able to write and produce software and distribute it out very quickly. Then I can have software that makes infrastructure. When Amazon launched AWS, now I can write software that spins up new infrastructure and makes brand new servers and makes tens of thousands of them. In seconds, I can do that. Then the big one. I can write software that makes software that learns. And then when that software learns, it can make more software. This changes everything. And this is why it's so important we focus on engineering and software and not just bunches of data sitting in a data lake somewhere. Because we want that magic. We want that same type of magic that Google has. The same type of magic that Amazon has, where it tells them when to ship from warehouse to warehouse. We want that here, and we won't get it through the ways we're collecting data today. We won't get it through 7-year ERP projects. We won't get it through collecting a bunch of data and having floors of data scientists trying to go through all the data and clean it up. That's not how we do it. ERP in the past has been designed for manufacturing or accounting systems, for accounting businesses or manufacturers. The oil patch has a dynamism about it. It changes all the time. The thing we did yesterday is not the thing we're going to do tomorrow, because we have different field hands, we have different formations that we're working with, we have different weather patterns, we're using different equipment downhole, things aren't the same, and we can't use the systems that we use to run manufacturing plants. That doesn't work for us. And it hasn't worked to the point where we've burned cultures to a crisp, and many of you hate information technology and you hate software. You don't want to implement more software. What we want is magic to come out of nowhere, to take all the data we do have and just turn it into good machine learning, turn it into AI. But that usually doesn't work, and that's what we're doing, that's what we've done wrong in the past, and that's what we're continuing to do wrong. Because great data science isn't free. Great data isn't free. And you don't get great data science from a bunch of spreadsheets or a half-baked data lake or something along those lines. We get great data science. We get the ability to do machine learning and do AI at scale that learns rapidly and continues to learn upon itself with more and better data if we do the data collection right. Useful data is quantified and qualified data. Useful data isn't data that we have to clean up after the fact. It's data that we capture the right way at the source at the time of collection. That is useful data, where we qualify it and quantify it, where we say this data was good, or this means good and this means bad. That is good data. That's where we get rapid development and disruption, and where we get the cycles where machine learning actually returns 50 and 100x value. But what we've been looking at is quick fixes. We want quick fixes. We want to jam our data together in a data lake, and we want to throw it over to some machine learning. That's a quick fix. What we really need to look at is data ecosystems and software ecosystems and pipes. How do we get the data in? How do we get the data then back at the source? Because our dirty little secret is that we don't care about the data at the source. We sit in corporate and we just care about that we have a bunch of data, and that's good. We don't care about the data at the source with the field hands, with the guys that are actually collecting the data, with how we design the sensors to collect the data. the guys are saying, well, this was good and this was bad. That the guys that are entering which asset is which. What was the service record on that pump? What was the service record on that downhole piece of machinery? What was the service record? And what's the maintenance history? And how much torque did we put on this thing? And did somebody say that was good or bad, or when it failed or why it failed? If we look at the value chain of the oil and gas industry and how wells get drilled, completed, and produced, we almost never think about those guys in the field, the guys back in the warehouses, the guys that are using this software to make real-time decisions. And we have to stop that. That has to end, because that is the origin of data. That is the origin of data where those guys say it's good or bad. And that down there is where you want to push the data. Because there's another dirty little secret in the software industry as a whole. And that's that machine learning and AI are commodity. You can buy those things. They're not magic, and they're not going to be a competitive advantage. They may seem like that today, but real disruption is going to come from getting the data right and getting your data pipes right. Because the AI, the machine learning, you can buy it. You don't have to have floors of data scientists to work on this. You can buy it. You can buy it from folks like Philip. You can buy it from Amazon. You can buy it from Google, depending on who does better, but it's commodity. That will not change your business. That's not the magic that's going to be your competitive advantage. It's the way you build your data pipes and the way you get the right, best, cleanest, most quantified and qualified data at its source that will actually change your business and what you're capable of doing. And I want to illustrate that with this little quote of somebody that does it really well. So you might think about Facebook as something that you can share data with your friends, you can share data around with your grandma, but in essence, Facebook is a massive machine learning powered advertisement training engine that employs billions of people, a lot of us in this room, to teach it how to serve relevant ads over to your sister. That is what Facebook is. And what they've done and where they're brilliant, and this is just one example of how Silicon Valley and the guys in different spots that are engineers and thinking about software engineering as software engineering get it right, is they think about how do I collect the best data. They spend billions of dollars on making your user experience, your experience of their software data collection, as good as it can possibly be. They have thousands of engineers that are focused on you guys, the end users, the guys, the field guys, the guys that are out there collecting data for them. They spend tons of resources on that because that's where the data comes from. And then they open source their machine learning. They give it away for free because their machine learning is not the difference. The difference is they collect the data in the right way. They quantify it in the right way. You quantify it in the right way. And I quantify it in the right way. And your grandma quantifies it in the right way. Because that's their goal. They understand that. They understand that if they do that right, they can build all the machine learning, they can do all the analysis and data science and AI that they want to do and just make that better over time. Because they're getting it quantified. They're seeing if it works. If you didn't know, which is kind of interesting on the Facebook side, if you're scrolling through an ad and you pause on your iPhone or Android and you pause for half a second to look at that ad, they're collecting that. They're quantifying the data on that because then they know you're interested in that ad. You don't have to click on it. You don't have to do anything like that. You just have to stop and look at it for a couple seconds. They're spending their resources on that because then they can do the machine learning on the backside. So real quickly, I'll spend about a minute going to art of the possible, and then we'll open it up for questions. So Amazon has taken over books, retail, electronics, warehousing, cloud infrastructure. Amazon's doing all that, right? They're doing amazing things. They're in the middle of the process of using all those machine learning tools that they've built to do things like I'm about to talk to you about. So Amazon's warehouse looks like a mess. And if you ever go look at it or if you look at one of their warehouses or see pictures of it, it's a mess. And they don't organize things like a library where you've got all the books categorized. They organize all their goods and services in the way that the machines tell them to, because they think you're probably going to buy this and this and this together. That's how they organize it. They organize it in the way the machines say, because that's more efficient than somebody trying to organize it. They do all that. They have these little machines now that are moving things around, trying to pick parts for you. They will actively ship goods from one warehouse to another based on what they think you're going to buy next, or what they think people in your area are going to buy next, because that's what they bought. You might have put it in your cart. You've looked at it 4 times. They're doing all of those things. They have engineers working on a single sentence. They have a big team of engineers, software engineers, not data scientists, working on a single sentence of, if you want it tomorrow, because they know if you get it faster, you'll buy it faster. You'll be more likely to buy because you don't have to wait, because we're really bad at being patient. So they have teams of engineers working on a sentence, little things like that, just to make it better, not for somebody back in corporate, not for a bunch of Florida data scientists, not for that, for us, to make our experience better, so that they can collect more data from us and that they can do all kinds of interesting things. And they've taken all this knowledge, all this machine learning, and then now I can go buy it. The kid that just graduated from a CS degree can go buy it for almost nothing and do machine learning at the scale and at the sophistication and level that Amazon does. I'll skip over the target and I'll conclude. We're in our infancy in this. If we want to fill up a bunch of data, we need to start collecting the data better and have it quantified ahead of time, so that we can do that amazing machine learning and do it at pace and feed it back to the people that need those decisions to be made in real time. We need to build data pipelines and software ecosystems. And the disruption will seem to come out of nowhere, because it's the folks that are building those data pipelines and ecosystems and collecting stuff at the user level and making it great for those folks who are getting all that good data. They're going to come in and disrupt it. It will feel like it came out of nowhere, because they'll have the data and the machine learning will just follow after it. So they're not magic. And one caution, and I'll end and we can do questions, is please ignore the buzzwords. Embrace the fundamentals of great software and great software engineering. If you understand that, you understand big data in a way that you can actually make use of it. If you understand why Facebook is successful, why Google's successful, why Amazon, why Apple, if you understand why they are successful with their end users, that gives us the ability to then build the right pieces of software to get the data, to do the amazing things that will make our industry wholly different in a decade. So, thank you.
If anyone has any questions, please raise your hand, and Sean will bring you the mic, and state your name and company, please.
Hold on.
Two minutes. Pretty much EPMG. So why do you think it is? I was thinking about this, because we have this over here, we have the seismic data management thing, which is not my number one thing, but I think about how much money we spend on seismic, and we have this whole data management, very mature practice around it, and you take something like completions data, where we spend millions of dollars on this operation, have incredibly granular data, and then we tend to throw it away, throw it in the trash.
Yeah.
So it seems obvious that we would be more mature in trying to get that data and capturing it, keeping it, but we're not. So I'd love to talk about why. Why would we spend all this money and do nothing with it?
My impression from working with field companies, working with this that half of the industry, we spend most of our time oilfield services and where that data goes, is it's real hard. It's hard to do stuff with that data. It's hard to collect it well. We as an industry are very backwards in terms of what we think about software, in terms of what we think about data. So I think part of it is hard. Part of it is when you get down to field service level and you're getting all that data there, and you start to get folks that, it's a cultural thing, you start to get folks that don't really value that or haven't seen the value of that. And so there's this chain of, okay, you collected some data, you probably collected quite a bit of data and completions, and then your company may maybe have pecking that in some other system, or they have some of that, or they got a bunch of spreadsheets, or they got maybe some paper. Maybe some of that got transferred, maybe some of it didn't. And then your completions engineer maybe gets some of that, but mostly what he's doing with that is looking at spreadsheets and manipulating data, and he doesn't have a place for it to go. So it really comes down to, it's really hard today because it's hard to get the data transferred. We do it in paper and spreadsheets and daily reports, and the thing we end up caring about on a daily report is this field was here instead of here. We get real mad about that. What we don't care about is that the data is collected at high quality, at high thoroughness, and at volume, and that it gets around. We're missing the ecosystem and data pipes. We're missing fundamental infrastructure that machine learning and data science are the commerce on top of the roads that you build, the infrastructure of the roads that you build. You don't get hotels like this and restaurants if you don't have the right roads. In our case, in this case, you don't get good data science. You don't get things happening with the data unless you have the roads to move it in the right way and store it in the right way and give everybody the right access in an ecosystem fashion. I think that's kind of the fundamental thing. Is today it's way too hard, and even if you do have a little bit of data, you might throw it over to a data lake, but you're not thinking about the engineering side of that and how do I feed it back to the completions guys because they work for a field service company, and how do I do that whole process? And because it hasn't proved valuable and it's real hard to do, I think we've kind of ignored it.
So we talked about this concept of a software engineer who is 100 times more productive than your average software engineer.
Yep.
But you don't hear about, oil and gas company paying a software engineer $3 million a year because he's producing that much more than any other software engineer.
You don't.
It just doesn't happen. In fact, most of them are within a relatively narrow range. The difference between us and an E&P and a company like Amazon is Amazon, they view their software engineers as their profit center versus their cost center. And,
Yep.
and E&P, it's often seen as a cost center.
Absolutely.
And we have things, deadlines that are artificial, that
Yep.
don't really correspond to anything in reality. And so we draw the line at some point. We say, this is good enough
Yep.
to get out there. My question is, how do you change that culture?
I'm going to be pretty blunt here. You remove it from the E&P. You cannot have good software engineering culture. You're never going to pay an engineer $3 million like Google does. You're not going to get it in an E&P, and let me tell you why. It's because the culture to do a good E&P, the structure, the management structure, the culture that you produce, to do that type of business is fundamentally different from a culture that understands that a good software engineer can be 100x productive, and you should pay him $3 million. It is fundamentally different. They're fundamentally different cultures, and I've been working with large enterprises, building software in and out of them for over 20 years. I've never seen it work where internal teams have the ability to act like the best software engineering teams in the world because of those things you're talking about, artificial deadlines. Your chief executive, your CEO, or your chief executive in that industry will almost never have the ability to have the same mindset and culture that Eric Schmidt of Google has. They're fundamentally different businesses. They work fundamentally different. The culture and business practices you need here are fundamentally different than the culture and business practices. They don't work. So you have to pull them out. A lot of companies, what they'll do is they'll do innovation hubs, pull it out, different culture, different operations, different management. They'll do that, but they can't be in the same building. They can't report to the same executive structure. None of that works. So you have to pull it out, or you buy good software from folks that are doing that are software companies. That's another way to do it. Or you hire great software companies. The only way to do it is to have a great software company that is not under the same management structure over here. It doesn't work. Never will.
All right. Thank you, Shane.
Thank you so much.